to this weekly webinar series of data-driven digital agriculture, What's Cooking. This is the 33rd webinar in this series, and we host all world's leading practitioners, thought leaders, innovators, researchers, CEOs in this series. And we have many people who join in from all over the world here. And I really am very happy to host today this very innovative work which is going on in Korea for a long time. We have been involved with the Korean researchers, agencies, private sector, public sector, government for a very long time in terms of a very dynamic knowledge and agriculture partnership. And I'll talk about that. But we also have just finished a flagship report on digital acceleration of food systems. And we would like to show a very short video which describes this report to begin today's proceedings. Vivek, can you show the video now?
Our global agri-food system sustains the world's ever-growing population, creates millions of jobs, and is critical in achieving the Sustainable Development Goals. But the global agri-food system is not fit for purpose and stresses the environment by generating up to 29% of greenhouse gases. And while there is an overabundance of food, 820 million people are undernourished worldwide. This is due to the global agri-food system being held back, partly by transaction costs and information asymmetries, which prevent profitable transactions. The agri-food system is complex, and it takes dozens of stakeholders and transactions to bring food from farmers to consumers. Transaction costs are incurred by business partners to find each other, determine sales conditions such as volumes, quality, and negotiating prices and return policies. Because of information asymmetries, which occur when one stakeholder has more or better information than another, traders and consumers cannot tell whether a product is high quality or meets their environmental or social standards. This costs the farmer profits, drives them to choose quantity over quality, often at the expense of the environment, and limits consumers' product choices. But through digital technologies and mass access to data, the world's agri-food system can overcome these obstacles and deliver healthy people, a healthy planet, and healthy economies. The World Bank is a trusted partner in helping countries' agri-food systems navigate the digital revolution. Our new report provides insights into the potential of leveraging digital technologies to transform the agri-food system. Digital agriculture can create societal gains with the 3 E's. Economic efficiency, through farmers being able to access multiple markets and lower costs through improved price discovery, buyer-selling matching, improved traceability, and quality control. Equity, through the inclusion of smallholder farms and marginalized populations. And environmental sustainability, through reducing food waste, better resource management, and rewarding environmentally friendly practices. Creation of and access to data allows new ways to evaluate small-scale farmers and agribusinesses' creditworthiness, improve their access to rural finance, and allows the design of affordable insurance products. Digital technologies also allow efficient government policy design, policy implementation, and environmental outcomes monitoring. These benefits are great, but digital agriculture also has risks, like a digital divide. Many people still can't access technology or sufficient internet and don't know how to use it. The second risk is data governance. Farmers' business and personal information can be exposed, tempting misuse. Lastly, the risk of limited competition. There are concerns that digital markets will increase market power and filter profits to a few digital technology providers. how do we ensure the agri-food system benefits from digital technology? First, governments need to increase access to digital and physical infrastructure for data and technology use throughout the food system. Second, policies need to support innovative ecosystems for digital agriculture through open data sets, digital platforms, digital entrepreneurship, digital payment systems, and digital skills. Equally critical is ensuring a competitive environment for digital services providers. We also need policies that protect data use and sharing against misuse, and make sure the agriculture policies maximize digital agriculture's potential for environmental sustainability. Through the digital transformation and with the right policies, the food system can deliver healthy people, a healthy planet, and healthy economies.
That was great. Thank you for sharing that. I'm going to have to use that all the time.
Thank you, Vivek. So because we just launched this report, I thought it's good to show everyone the short summary of the report. And Vivek, can you put the slide on the website? We also launched a collaboration for development external website. And Vivek, can you show the link to that now quickly so that we can get started? So basically all the information which you are seeing now coming from these webinars and all is available at this website. And we have launched a global platform, and it's called, it's also available at www.worldbank.org/digital agriculture. So because people ask a lot of questions of where this material is available and all the things which our teams are doing this report, everything is available on this website. Please look up this website and send us your suggestions for that. So now I would like to shift to the webinar of today and really come to the top exciting topic which we are featuring today. And we are today talking about the smart farming in Korea. And Korea is really working on a smart farm innovation valley concept, something analogous to Silicon Valley, but really looking at a number of smart farms which are clustered in a particular area and are connected digitally through with a network. And when I was in Korea, I had the privilege of going and visiting a number of these smart farms and see how they are connected with each other. And it's so good to see that a lot of young people are really, running these digitally and data-enabled smart farms in Korea. And so we thought that it would be good to share this experience with, other countries, as well as what Korea is doing, both in Korea, plus also taking these lessons to other countries. So we have a very exciting panel. We have Ms. Yong-Ki Hwang, Director, International Agriculture Corporation, Korea Agency of Education, Promotion and Information Services in Food, Agriculture, Forestry and Fisheries, EPIS. And then we have Dr. Jongwon Park, External Specialist in Department of Global ICT Consulting Team, National Information Security Society Agency in Korea. And we have Sangum Lee, who also works with Department of Global ICT Consulting Team, National Information Society Agency in Korea. And we have two discussants who have also worked with the Korean ecosystem for some time now. Ji-Hai Kim, who is the Senior Digital Agriculture Specialist in Agriculture and Food Global Practice, and Yunju Yi, Senior Environmental Specialist in Environment and Natural Resources in South Asia there. And it's good to have this panel. So what we'll do is that we'll start with 40 minutes of presentations and then 5 minutes each of discussion. And then we would also request you to start asking your questions in the chat when the presenters start presenting, so that we can harvest all the questions and ensure that they are able to respond to your questions as they come. So I would request you to be active on the chat in order to have a good discussion at the end, because if you start asking only questions later on, then it will be difficult for us to factor these questions there. So I would now request Ms. Huang to come and make the first presentation, please. Thank you. I think you are on mute. Can you unmute yourself, please, Ms. Wang?
Okay, hello, can you hear my voice?
Yes, we can hear you now. Please go ahead.
Okay, thank you. Hello, good morning in Washington time. I'm Young-gi Hwang, the Director of International Cooperation Department of EPIS from Korea. First of all, I would like to thank you for giving me the first opportunity to introduce smart digital agriculture in Korea. Thank you all. Thank you for Parmasha and Unjuli and Jiki and all participants of World Bank. Okay, let's start the presentation now. I will tell you the table of contents as follows. First, let me introduce the EPIS briefly. EPIS was established in 2012 through the integration of three institutions to efficiently promote the development of agriculture human resources, informatization, value of rural culture, capacity of agriculture management, and support integration, international trade of corporations. EPIS is specialized ICT in agriculture and the capacity building for farmers. EPIS has 7 main functions: spread informatization in agriculture and promote culture and values in agriculture and rural areas, fostering human resources such as enhancing the technology level and management of agricultural management organizations, training professionals in agriculture villages and the food industry. Also, EPIS supports trade policies in agriculture, rural, and food industry for international cooperation, etc. There are 4 headquarters and 21 departments under president and vice president. Okay. EPIS is implementing smart farm ODA projects in the Philippines, Indonesia, Cambodia, and Vietnam in consideration of the national climate, economy, and technology based on many years of project experience in digital software-based information service, education, and public relations. Smart farms are not necessarily smart artificial intelligence for all environments by themselves and don't need to adopt all high technology. They need to implement proper smart farm considering each developed country's situation or succeed is for the ODA perspective. It's very important to analyze local environment well in advance and then localize smart farms in each nation's characteristics. In particular, investment costs will be the most important factors in economic conditions in underdeveloped countries. It is more important to adopt smart farms that utilize appropriate technologies by considering the local national environment and at the same time considering the cost-benefit structure rather than applying high technology unconditionally. Okay, next is the background of the applying ICTs. In the meantime, Korea has been aiming to the decrease in the number of farmers and the increase in the proportion of business owners aged 65 or older, as shown in the table. Fresh agricultural products have decreased the export to Japan and decreased investment, leading to stagnant agricultural growth, income, and exports. However, there is now a new wind of change in Korea agriculture. The rural population is increasing. The number of people working in agriculture, forestry, and fisheries is increasing every year. And the average number of graduates from the College of Agriculture and Fisheries is around 4,700, and their age is 32 years old, and then the average annual sales is about $80,000. Smart farms apply for ICT technologies such as the IoT, big data, etc. This refers to a farm that automatically controls the optimal growth environment. Through this, the environment and growth information can be collected, the environment can be optimized, the precision and automatic condition can be made to provide the optimized growth environment, and productivity can be improved by reducing input and labor. In addition, stable production through the year with the controlled state-of-the-art facilities can meet the needs of consumers, such as safety, uniformized, and supply through the year, leading to increased exports. In addition, it will be possible to create jobs such as smart farm managers and professional growers, and jobs in related industries such as system developers and consultants. Therefore, the Korean government is trying to induce innovative growth in agriculture by spreading smart farms that incorporated ICT technology in existing agricultural field. Let's see what progress has been made so far. Smart farm-related markets in domestic and overseas continue to grow with the development and the spread of ICT-related technologies, especially in Korea, which has grown on average of 10% annual over the past 5 years. Since 2014, the government has seen smart farms as a key growth engine, supported by human resources development, investment, technology development, ICT equipment supply to facility horticulture greenhouses and livestock facilities. The spread of smart farm is rapidly increasing due to the spread of the awareness of smart farm performance and the government policy support. Let's tell you about smart farm concept and its effort. What is a smart farm? Smart farm is a farm that automatically and remotely analyzes the environment of agricultural products such as horticulture, livestock, and open land by utilizing automatically facilities and information and communication technology to analyze and manage the growth environment. Smart farms can reduce fertilizer, water, and energy input while improving quality yields to overcome the decrease in agricultural population aging and small farming scale limits, and improve agricultural competitiveness. Smart farm is mainly classified to 3 major types in Korea: the horticulture, open land, and the livestock sector. The environmental control of the greenhouses monitors the humidity and temperature CO2 of greenhouse and maintains optimal growth environment for crops through PC or mobile, and also providing an environment for growing vegetables and flowers using smart greenhouses, the remote control of window opening and closing, and feeding of the nutrients. Intelligent livestock farm can monitor environment such as humidity, temperature, and other conditions, and supply feed and water automatically by PC or mobile devices. Smart orchards can monitor the temperature, humid weather conditions through PC or mobile and irrigate automatically, and also manage the disease. Productivity can be improved through the database scientific greenhouse management, such as facility modernization, smart farm installation, and expert consulting. In the case of tomatoes in Hwasun region, you can see 55% increase in production, a 50% decrease in labor, and 35% reduction in energy. As a result of analyzing the effectiveness of introduction smart farm farmers, you can see that labor cost and management cost has been reduced, productivity and farm income has improved. The next is the way to promote smart farm. The government is planning to spread the 7,000 hectares, which is the 70% of the 10,500 hectare greenhouse smart farm by 2022. To the end, the government aimed to ease the burden on farmers by supporting ICT-linked facilities, such as scale of high-tech agricultural complexes, vertical farmers to diversify smart farm types, demonstration of old field crops burden expansion. The government planned to dissemination the livestock the smart farm to 5,750 households, which is 25% of full-time farmers by 2022. It will preferentially support the development of smart farm models and the expansion of applicable livestock through case analysis and the modernization of facilities for farmers that want smart livestock. EPIS establishes a system to support the site. The RDA, the Agricultural Technology Institute, directly field technology, and smart farm related companies organized field support groups and support for smart farm farmers. It supports smart farm farmers' difficulties in installing and operating smart farms by supporting all processes such as pre-installation inspection, installation stage, and the completion inspection of smart farm through consulting by specialized institutions. In conjunction with agricultural university and agricultural technology centers, the company continues to support the strengthening of the capability of the smart farm farmers by operation field experience centers by level. So far, it is not easy to have a nationwide follow-up management network due to the small size of domestic smart farm companies. To this end, the company is strengthening its expertise and the collaboration through the operation of field support centers by region and the joint follow-up management system among production companies. Through the official recruitment and evaluation, the government selected the target area at Jeonju, especially Gimje, and Gyeongbuk in Sangju in August 2018, and selected 2 other locations in Jeonnam, actually Gohung, and Gyeongnam in Miryang in March 2019. Thank you for paying attention to.
Thank you very much, Ms. Wang, I think, and also thanks for finishing absolutely in time for your presentation. It's a very exciting program, and you can see that this is just hot from design and implementation, So we are bringing you, concurrent lessons from what's happening in Korea, and it's very good to share how Korea is looking at futuristic agriculture and creating some analog conditions to what I would call is not industrial, but a new kind of agriculture, which is more data-driven and digitally driven there. And thanks a lot. So we would now move to our second presenter, Dr. Jongwon Park, who will, from the National Information Society Agency, who will take us on how these lessons are being taken to other countries. Dr. Park, go ahead.
Actually, it's my turn.
Oh, Sangun, you will come first? Okay, sorry about that. So I didn't know the sequence, so please go ahead.
Yes, okay, I share. Okay, can you see the presentation, right?
Yes, we can see that. Absolutely.
Yeah, welcome to the today's webinar. Hello, everyone. My name is Sang-won Lee. I'm the external specialist of NIA in the area of agro ICT and smart farming. I've worked for government for 16 years at EPIS. EPIS, you just hear from Ms. Huang. I worked there before, and then those time I have distributed and spread agricultural ICT and smart farm at home and abroad. I also carried out the smart farm ODA project for the first time in Asian country, the Philippines. Recently, I have been doing TA projects of NIA to introduce smart farms to developing countries such as Sri Lanka, Vietnam, and Myanmar, and etc. Today, I am very delighted to share my experience on smart farm to World Bank friends. I'm going to give a presentation, joint technical assistance on ICT with international organization and digital agriculture projects. After giving my presentation, my colleague, Dr. Jung-hwan Park, will give a presentation, digital agricultural technology against climate change and Malaysia digital agriculture project. Okay, then I'll start my presentation from now on. First, I will introduce NIA and its joint TA on ICT. NIA, National Information Society Agency, is a core agency of the national informatization entrusted by the government and the people with providing policies and technical expertise. NIA is mainly working on the two ministries of the Republic of Korea, the Ministry of Science and ICT, and the Ministry of the Interior and Safety. NIA has 8 focused areas: ICT policy, ICT infrastructure, data, open data, e-government, ICT convergence, digital inclusion, global cooperation. So one of the focus areas of the Department of Global ICT Cooperation is ICT consulting. The ICT consulting has been done with the international organizations and the partner countries to promote collaborate TA of ICT. Through TAs with the international organizations such as World Bank, EPIS, ITU, NIA is helping digital transition of the partner countries. Since 2009, NIA have carried out 47 TA projects with 12 international organizations and 40 countries. The service areas are like ICT consulting, joint study, capacity building. These are domains, and then these are the technologies they are dealing. So this is the this slide shows joint TA process as follows. First, the country or international organizations request TA to NIA, and then NIA team up and then to implement the project. So from the internal and external experts. So and then NIA execute the TA project within usually within 1 year period. And then NIA share the result with international organizations and also the countries. Actually, NIA does not carry out project directly, but NIA do the best to ensure that the follow-up projects are well created with the result of the supported TA. Second, let me explain why developing countries need smart farms. You can see the difficulties of agriculture. It's not only the developing countries' problem, it's the all countries' problem nowadays. The natural disasters and environmental pollution due to indiscriminate use of agricultural chemicals. And then small size of production and low value crops. So because of this, the farmers are having difficulty in poverty. So to address these problems, I think modernization and then climate-controlled agriculture and high-value commodity such as high-value crop, tomatoes, strawberry, paprika, those things should be introduced. So the solution, I believe, smart farming is it will be the solution to address this kind of problems. You can see the difference from the pictures to the left and right. So the left side pictures is the picture of tomatoes produced locally, and then right side is the smart farm produce. And then you see the right side smart farm produce has high. It has a very high yield because you can produce for more than 10 months. And then it provides the uniform size. And then since it is GAP standard, you can expect high price. And then as you see here, it has it provides high sugar content. So because of this, you can expect high price. These are the pictures for smart farm. The right side is soil-based production, and then left side is soilless. It's nutrient system. So when you consider the smart farm, many people think smart farm is very high tech and very expensive, but it doesn't necessarily to be a high tech only. So you can try this soil production first with a very low cost, and then if you earn money, then you invest the money to the soilless production, and then you can expect higher yield, and then you can earn more. So that kind of approach you can try. So when we consider the smart farm project, it should be a fully value chain approach. From the farmers, and then we select the farmer or the cooperative, and then we install the smart farm, and then divide the farmer into the smart farm, and then they get the training. But we don't stop here. But we also train them how to package and how to branding the names, and then we also prompt them to adopt the smart farm after they finish the training, and then the smart farm will be diffused to their farmland. Optionally, the Korea Smart Farm project provide the work visa program for the developing country farmers. Yeah, these are the possible commodities for smart farm. You can see the cherry tomatoes and celery tomato, and then very colorful paprika, and then pepper. And then for the cool climate, you can grow strawberries. And for the hot climate weather, you can grow melon. These are the possible commodities. And then now we will see the achievement of recent smart farm TA. So this is the TA done in 2018. The MASL is Mawali Authority. Mawali Authority is under the President Office. It's very powerful organizations. And then Mawali so requested to the pre-feasibility study to NIA in 2018 to cooperate among IFAD, Mawali Authority, and NIA to pioneer the chance to adopt smart farm technology in Sri Lanka for smallholder agribusiness and youth farmers. There was a IFAD set project there, so we linked this program together. So this is the 5 months project, TA project, and then the component like this feasibility analysis, and then we propose applicable smart farm model to Sri Lanka, and then we propose implementation plan. And then this is the final report, and then it took 5 months, and then we visited several places to see the which place is the suitable for the smart farm. And based on that, after the finish the TA, luckily we get another project EBCK fund through NIA as well. And then with the help of these two projects, we are able to sign MOA with the local company and Mawali Authority. The company is Agro, which is producing strawberry in Sri Lanka. And then with the result, we are able to send our smart farm materials to Sri Lanka. So it's in Sri Lanka in Kotumale now, in our Mawali site. However, we cannot install this at the time because of the COVID. But after the COVID, we will do. So NIA and APT is funding, and then Jagro, they invested 75%, which is almost $340,000. And then Korean company Chinan invested 25%. And then the project includes not only the installing the smart farm, but also the training 90 farmers, young farmers, and then the farmers, cooperatives, and then it also create brand. This is the holistic step. So we finished this TA, and then now we are in the stage of model farm. And then after that, we will diffuse, and then we try to seek other funds from ODA or loans. Because farmer themselves, it's very hard to adopt a smart farm in their farmland with their own money. So you have to link the loan program to farmers. And for this, I will share the TA program, another TA program with World Bank in Myanmar. So NIA initially approached World Bank Group to cooperate in the field of ICT and smart farm in early 2020. And then this is to cooperate within World Bank and NIA to develop the component one, agricultural productivity enhancement and diversification of World Bank's NFASP project. There was an NFASP loan project happens in Myanmar at the time, so we linked this program together. Then it's also 6 months program, and then these are components. And we did several survey. We couldn't go there, so we did it through the webinar and online. And then we come up with some kind of results, and then we gave this result to the Myanmar government. They are happy with the result. So the result is like this. The Nepido, we proposed mango net greenhouse for mango, and then paprika greenhouse, and then small container farm for strawberry. Even though it's very hot weather, DAR, the counterpart of Myanmar, they are research agency, so they want this strawberry container farm there to see what is, whether they can grow the strawberry under the hot weather or not. And then in other area, we proposed paprika, and then Shan State, which is 1,000 meter high, so it's very rather cool area. So we proposed strawberry there. So this is the whole vision. So after finish this model development, we try to apply and diffuse through the ODA and loan project program to improve the productivity of high income crops in Myanmar. So it elaborate a little bit more. We finished this TA program, and then with the result of this TA, we are able to link this to the World Bank program, which is going on now in Myanmar as a loan. And then also we proposed this result to EPIS timely. So EPIS proposed another project, ODA project, to the MAPRA. And then there is another ODA project will be initiated in 2022. And then in the future, we'll also propose the loan project. So this is the outline of the project. I'm not going to elaborate, but the difference from the World Bank loan program of Smart Farm and this MAPRA program is the location is only 2, and then this MAPRA project has the open land farming using the drone and irrigation system, and then since it's very hot weather, it focuses on the leafy vegetable in the Pido area. And then Shan State, it proposed tomato, paprika, and as well as strawberries. Lastly, I'll show the Smart Farm case in the Philippines. This is the PPP type ODA program. So EPIS and then other Korean companies proposed this ODA project to KOICA, and then KOICA funded 70%, and then private investments invested 30%, and then it is a whole 4 years project. And then the component is like establish smart greenhouse and operate system, and then enhance distribution channel, and then farmers capacity building. So in the first year, we developed 3,300 square meters greenhouse in BPI Baguio, which is located in 1,600 meters high. And then another project in Rijal Tanai under the complex of DA Rarej. Its altitude is very low, like 300 meters, rather hot. So, but we established like 4,200 square meter greenhouse there. It's very close to Manila. And this is the process, how to construct the greenhouse, the groundwork, and then building the greenhouse, and the internal jobs. And then this is the idea of the whole greenhouse. And then this greenhouse has climate information system, and then sales information system, and then plant growth information system. So you can do the scientific based farming. In the component, it also has short-term training, 1 to 2 weeks, and then long-term training for whole cropping period from 6 months to 12 months, from seeding to seedling, transplanting, and wiring and cultivating. You can see the real pictures from the site. This is the Tanai and Baguio. They produce very high quality on different colors. And then they also produce very high quality paprikas, which has got a lot, which we could sell at a very high price in the market. So culturing, and then processing and packaging, and then we also bring up some brand K-Sweeto there. So as you see, the bricks is like a 12.6, which is higher than Korea, actually. And then through this project, we expect we witnessed that the yield has increased from 3 kilo. Actually, open farm they have 3 kilograms per square meter. Through this smart farm, we expect 10 kilograms per square meter. Because we grow very small tomatoes. If we grow bigger beef tomato, then the yield will be higher. And then the sales increase in the first year. Actually, we give the free promotion to the people, so we couldn't get much profit sales. But in the second year, only up to first quarter, we had the sales of $40,000. But after the first quarter, we had to stop because due to the COVID-19. Otherwise, we are expecting more than $100,000 in this one site. And then this.
Sangun, I think we are reaching almost 40 minutes now, and so if you want Jungwon to get a say, then you'll have to wind up your presentation.
This is the last one. So as a result, we are spreading the project. So we are making another PPP project in the Philippines together with the local farmer 50%, and then private investment 50%. So yes,
you will get a chance to answer questions because there are a lot of interesting questions coming in. Please start looking at the chat box. The two presenters, because I think we should start answering some questions in the chat while it's going on. So over to you, Jongwon. Songjai Jang is answering a number of questions while the chat is going on. So I think it's at least starting a discussion at the chat level. So I will now quickly go to my colleagues GI and Yunju to make a very short kind of discussion questions, and I would like them to focus on the applicability of this in your own context, and what do you see as the potential way by which this can be, used in the countries where we are working on. So over to you, GI first, and then Yunju. So if you can be brief, then we can get in questions from the audience because there are very interesting questions from the audience. GI, over to you.
Sure. Thank you, Parmesan. Thank you, Ms. Huang, Mr. Park, and Sang-Hoon from EPIS NIA. Sang-Hoon, great to be reconnected in your new incarnation in NIA. I think you were humble about your career in EPIS. Not only you made an impact on ICT and agriculture in Asia, but you made lasting impact and impression with our clients, especially in Uganda, in Africa. So I expect to work and be connected with you again through NIA also, and continue work together in Africa region as well. Our team was in Korea actually in 2019. Parmesh was there as well, and we were very fortunate to have opportunities and meetings with Ministry of Finance officials as well as MAFRA, Minister of Agriculture officials, and they introduced us. At that time, I think they were concluding the feasibility studies of the Smart Farm Innovation Valley, and we discussed at length on the applicability of these models and what is expected and what are the futures for these types of investment. It's a huge investment. It's $24 million for one site, and you're going for 4. It's almost $100 million projects, a massive amount. And we also got to see how domestic and smallholder farmers are reacting to this, and what were the dynamism of young farmers or strive to be farmers sort of population so yeah, we were very fortunate to be in the middle of that domestic discussion at that time. And it's really great to see how it unfolded now. And you're piloting this at great speed. So congratulations, and then thank you for all this presentation. Yeah, I just wanted to emphasize on really the 3 points that that is really impressive for me. One is that how government is really moving in this right direction, given that in global markets, smart farming is an industry that grows over like 13.3% annually. So I think as a government, this was an investment to see how you can also achieve market and dominate also with the Korean technology. So kudos. Secondly, I really love this model of rental smart farm for youth farmers. This is really striking a lot of, I guess, points, the pain points in Korea, which is the trend of the aging farmers, right? And then also the fact that unemployment rate for millennials and recent new graduates is really high. There's a lot of competition in the traditional industries, and really the Korean economy needs to find better ways of providing formal jobs and profitable jobs with future, right? And thirdly, I think this will actually bring the problem of population density in Seoul and ease sort of transferring of a lot of economic energy and dynamism to rural areas. When we visited Korea in 2019, we visited with a lot of our clients from different countries all over the world. Some of my colleagues who's joining in this webinar here were with us there. And one of the things that I heard a lot from our clients who were with us there were like, I see so many people when we are in Seoul, and we visited a lot of farms, smart farms in rural areas, and they were so struck by the absence of people there. But then there were so good infrastructure, and they actually didn't believe that we were visiting rural areas, one. And then they were also quite surprised that they don't really see a lot of young people, and just really lack of the movability there. I mean, people moving, right? So I said, like, that's because 1/4 of Korean population is in Seoul. And that is actually a political and I think public policy problem. And I think investing in youth in this way will give us a high return in terms of, again, addressing the pain points, these 3 points, the aging farmers and unemployment of youth, and also the high density in Korea, which creates inequality. And the third point that impresses me is this cluster approach, which I think brings a lot of innovation, energy, and it creates ecosystem as it is, right? And the continuous loop of testing, demonstrating, and taking the practitioners to the researchers, and then bring all this learning back to the innovation pad, and then going around all this innovation stage, and that is like you're building really the Silicon Valley for agriculture there. So that's absolutely fantastic. And yeah, I'm quite impressed, and I would be very interested in continue seeing how this unfolds, and what are the learning points for our client countries. So I wanted to actually conclude by giving you what our expectations and recommendations are, especially given our previous sort of engagement with the government, and also not only government but with farmers in Korea, and also observing some domestic discussions around this. So one is, I know this it's one more important thing would be, and this was the concern from the smallholder farmers who are actually expressing their voices against this type of investment from government, is that you are doing all this very, expensive public investment, but without clearly linking all these high value crops, high value chain crops to targeted markets. And I think one of the government's strategy was, increasing the export. However, with the surplus, with this new technology, surplus production means, lower price. So how to address this domestic concern from smallholder farmers about increasing the domestic competition between them and also smart farms is something that I think the government and together with all the farm cooperatives should address, and it will actually give a lot of lessons for our clients and for people like us who would like to minimize the risks of this type of investment. We're not questioning the direction of this investment. It's absolutely needed. However, investment of this volume and also, this transformation always will meet some concerned voices and existing farmer and farm cooperatives resistance. So that would be really interesting to know from your experience, what is the current status on that and how it's being addressed. Also, supply and demand issue. Like I said, the high surplus means less price, and it's good for customers, it's good for consumers, but it's not a terribly good news for farmers. So are we establishing a good export market? How are we controlling the supply and demand? And secondly, I would be
Jia, I'll have to ask you to conclude because I think we have to give a chance to the people who have asked questions. They're waiting very patiently. Okay.
Yeah, sure. So my last comment is how to invest in the World Bank project with you. And I think one of the ways is to see how we can approach this in a modular approach, meaning we can go this big scale at once, but there can be some modular approaches, and that's what I want to maybe continue our discussion together with you, Ms. Kwan, Mr. Park, and Sang. Thank you.
Thank you very much, GI. Over to you, Yunju. And I would also request you to be brief and really focus on one or two aspects of the presentation. Thank you, Yunju.
Yeah, I'll be really quick. I think, first of all, we leave Korea's domestic issues to Korea, and I'm concerned and interested in the application of this to our client countries. And there's two key areas. One is, it would be great in the future if you could talk a little bit more about your future thinking, because obviously you're building an economy appropriate for where you are at your stage of economic need and climate shifting. And that kind of basis of rationale exactly is what our clients need to hear, that countries like you are getting ready for a future and needing to look at food security in a much more long-term way with climate change and cost variables for your own country's own survival, right? So I think it's really good to talk about your rationale in the future. The second thing on the costing, one of the things it would be great if you could do a bit more on explaining the economic benefits and losses. You've done a little bit of analysis here about where you see climate shift or the role of change of agriculture productivity affecting the economy in terms of loss and gain. And so I know that in Korea, food security already is an issue, period. It's something that you need to fix. And I think that kind of national concerns or need context is really kind of useful around that. Last and really quick, third is, I think you've done something really impressive. So I'm temporarily based in Korea right now, so I keep seeing commercials everywhere. There's a very young girl in pretty fancy outfit and doing agri farming on her phone. You've made farming very sexy for very young millennials, so I think that's quite an achievement. I think that's a quite good lesson that we want to bring to our client countries, because not everybody has to go into a big city. That's it. Thank you.
A lot, Yunju, for being precise and raising very important points. I will now take some of the questions from the audience, and then I'll pose to each one of you for the questions which are relevant to you. I'll cluster them together so that you can answer that in one shot, and I'll go in the same order in which you were there. So, and I'll give preference to the questions from 3 teams which have joined to us from the field. So we have Ladisi from China, who coordinates our program in China. We have Ellie, who coordinates our programs in Philippines, and we have Mio, who coordinates our programs in Myanmar. And they have asked very specific questions. And I would like you to respond to those questions much more clearly. And I think that's something which will be important. So Ladisi has a very good question. He says that, can the small farm size be viewed as an opportunity for adopting smart farms rather than a difficulty? And the land use efficiency can be increased through smart farms to producers with binding land constraint, especially if they produce high value crops. So can we now look at this smart farm as an opportunity for people who either don't own land or have very less land? Conventional thing is that we go to the farmers and only work on smart farms with people who have already done agriculture. Or are we talking about, as we're talking about the millennial farmers, the new generation of farmers, the young farmers who know a little bit more about data? Is this relevant to them? Or are you still looking at the existing farmers as you did in Sri Lanka? You work with the Mahiwali, with the existing farms. And what's the profile of these farmers? This question is coming again and again. What is the profile of these smart farms? Who will be running these smart farms? So I think this is one question I would like all of you to consider when you are responding to that. The second question comes from our colleague, Mio, and she says that countries like Myanmar may not have access to good quality of materials, machines, equipments required for smart farm, such as nutrient control, temperature control system. How do you overcome these concerns? Because it's not about just a farm, it's about machinery, equipment, and IoT sensors and all. And if you don't have that industry of that kind developed in the country, is it always going to be imported from outside, and then its applicability is going to get limited? So how do you overcome this constraint of creating a local industry to create equipment, material, and all that? So it's a very good question which Mio has asked. And then Eli from Philippines has another interesting question. So he says that are these smart farms can be done at the cooperative level or at the member level? Because we are working in World Bank with number of farmer organizations and cooperatives which are working with a lot of smallholders. So can this investment be done at the cooperative level? And then it's easier then to maintain and sustain this approach, as opposed to doing with smaller farmers who can never sustain this approach. So people are skeptic that small farmer holders can, without substantial, even in Korea, you are giving a lot of government support for this, and then only it's working. And if you don't give government support, will this crumble? So this is a question which is also something can we do this with cooperatives which have higher capacity to output markets, technical financial services with that? So these are interesting set of questions. And I would like Ms. Wang to answer this question about which kind of farmers will adopt smart farming. And this concept of the innovation valley, which combines incubation, technical assistance, and support, ongoing support to these farmers on an ongoing basis. How will this work? Which are the category of farmers with whom it will work? So Ms. Wang, first question is to you, and then I'll come to the 2 other presenters with a specific question to them. Ms. Wang.
Your first question is who is the educational farmer?
Yeah, which farmers is this going to be applied to? Is it going to be younger farmers? Is it going to be applied to cooperatives? Is it going to be applied to which? What is the how are we going to, target or segment the target of this smart farming approach?
Okay. Okay. First question is that the government supports farmers who are registered in the farmers cooperatives and also those who are in association according to the law. So we just in definition of the in the law we just support the farmers and the farmers cooperatives and can just apply for getting the to get the funding from the government to install their own smart farm. And then also some farmers who just cultivate vegetables and horticulture or mushroom, they can apply for their the supporting funds from the government.
So these are farmers, cooperatives can apply who are doing that. Small farmers who are doing horticulture and vegetables, they can apply. And I want to ask you a follow-up question. The Smart Farm Innovation Valley, who is the target of this valley? Who is going to join that Smart Farm Innovation Valley? Which kind of farmers will join there?
Yeah, actually, as I mentioned, as I explained it, some young farmers can younger.
근데 박사님 잠깐만 이게 경험이 있는 사람을 넣는 건지 아니면 일반 어린 사람이 들어가는 건지.
No qualification.
So these are non-experienced farmers. So they're not farmers yet. If a 25-year-old wants to start farming, they can apply.
Okay. So it is the millennial farmers who are the target of that. Correct. Okay, fine.
Yeah.
So let me go to Sangun now. Sangun, you heard about the applicability of this model. You have already taken this in Sri Lanka and other places. Basically, you have tried to do that. So how do you see this being applied? Like what Mio is asking, that if you have constraints on equipment, machinery, so what are the limitations and how do you overcome those limitations when you take the smart farming approach to Sri Lanka, Myanmar, and other countries? Can you have your views on that, please?
Yes, based on my experience, actually those developing countries has very limited industry, especially this smart farm agriculture. So it means they don't have the materials, and mostly they import. Currently, they are importing from various countries, including Korea and Netherlands and then Turkish and China and other countries. So I understand the question why because of the limitation of the material, we have to. I'd like to share this information. This year we had FS feasibility study in Uzbekistan, which is to install the agricultural material R&D, smart farm material R&D center there, and then educate the people there. So that will be another the solution, because up to now the countries itself, they cannot produce the advanced technology by themselves. So we not only giving the selling and bringing the material from Korea or the countries, we also have to set up some industry for themselves to sustainably produce the materials there. That's the one option.
Thank you. So I think there is a lot of accompanying investment required. So the question people are asking is, what are the enabling investments we will have to make in order for this to not only get piloted, because the purpose is not just piloting, purpose is to go to scale. So what are the kind of investments required to do? So you said that you need to invest in the whole R&D architecture for bringing equipment, material, and all that in the country there.
Yeah.
Okay. Now, related, yeah, go ahead.
All one inside together with the production side and then R&D center, and then the training center all together. So they can learn from how to make the materials, and then they can learn how to do R&D there, and then they use their technology on the farmers.
So Parmesh, one thing I could say is one thing what we're seeing in Korea as they roll out in their own country is to take a holistic approach on the investments they're going to do nationally. So maybe that's the kind of approach our clients can do, where if they're going to do investments with the World Bank, maybe we can see how we can connect the dots so that our agri, our environment, and these projects can go hand in hand, or co-location, for example, in the urban projects. Just
so I'll come to Dr. Park now. So I think Bunju raised a very important question on the economics of this, because ultimately agriculture and farming and smart food is about economics also. So I think you gave very good examples of B2B, B2C. I think that will really make it more market oriented, and ultimately our experience globally in the countries which have done precision agriculture and smart farming, whether you take Netherlands or Israel, is they have really built an architecture based on the commercial part of it. It's like it is part of the transaction. It works better where, as GI was also saying, that if you have a very good high value exports, and then high value exports, this technology works. But if you are primarily producing it for local market, and if you get more produce coming in, the prices drop, and then even the small farms are not able to make money. So what is your thinking about this, and can you give us some sense of the economics of this, Dr. Park, if you have done some analysis on that? Ballpark. We are not asking you to give exact figures at this stage, but what will it cost?
Good question, but my answer will be much longer. So I'd like to shortly about your question. Smart farming is the concept of the smart farming is very various kinds of the concepts. One of the kind of concept is for the control the price of the agri product. Okay. Smart farm focusing on the gathering data and analysis, and then after that more useful or dynamic information to the farmers or SME, for example, the small and medium enterprise of the agriculture, something like that, instead of not control. Control is the second or third goal of the smart farming. Okay? So maybe my answer will be the proper answer about your question. Anyway, yeah, your question, the pricing or market or anything about that, we can solve if there are problems. Then we can solve using the proper data. Okay, or how about this kind of in the past, traditional farming has been maintained mostly by our ancestors, passing on their experience. I mean the young farmers problem experience the future generation in some form before the age of climate change. However, in the future, the age when the climate change begin and its climate change damage is very severe, young farmers who will be farming will no longer be provided with meaningful solutions, such as their previous experience of their father or their grandfather, something like that. As one of the several solutions I propose is the proactive farming by making predictions that required many types of data, such as pest and pest control, as well as analytics and the learning engine. Smart farming is more meaningful, not only for the improving convenience or the more produce, anyway, through automatic factory automation, something like that, such as FA. But for the producing high quality data at a low cost, we have to pass at least a lot of data to young farmers. Of course, we make types of things as possible. I think World Bank can consider future-oriented project that proposed cooperation between countries in this kind of area, in this kind of project. Okay, yeah.
Thank you.
Right before your question about the young farmers, I think that's right.
Thank you.
Anyway.
So unfortunately, we'll lose a lot of people now because we have run out of our time at this stage. But
yeah.
I really would like to thank all the three of you, Ms. Wang, Song Lee, and Jungmin Park, for sharing the real experience, because you are sharing what's going on right now. You know, it's like a live project because it's not finished yet. It has a lot of things that are going on, and I think we can't expect all the data and all the information to be all available, but at least you have shared with us the trend of where you are going with that. So I would just like to briefly summarize that we clearly are looking at what do we learn from the Korean example. First, I think I clearly see that this approach would be used primarily with millennial farmers, the young farmers, who are more data oriented and other kinds of things. So we would work more with those farmers. And I think Indonesia clearly is also asking for us our advice on how to work with 50,000 millennial farmers. So I think this will be an interesting collaboration to see how we can develop that collaboration on a millennial farmer project, which will be from beginning, not start with only traditional farmers. It starts with younger farmers and brings them into the thing. And as Innovation Valley, what Ms. Wang was describing, you have batches of 60, 100, 150 farmers coming in, and they set up a new kind of architecture, where you provide them incubation, data services, the analytics, and also probably market support, because you will require an e-commerce channel to go with this. So now if you take China's example of what Pinduoduo and others are doing, they are really using data for a lot of farmers and then linking them with consumers. Why they are able to do it? Because they have a strong e-commerce channel on supplying food to the Chinese consumers. And they are able to differentiate where this food is coming from, the quality, and all that thing. So I think what this requires is a good market interface, for what to do. If you want to do with millennial farmers, you don't want to make them less money. You want to make them the kind of money which Songan was talking about, the $100,000 kind of money. Then only I think young people will get attracted to them. They will not get attracted by things. The second would be what GI was describing as modular approach, where people don't do agriculture full time, but they use it as one of the opportunities. A lot of consumers in urban areas would like to produce some of the food and know where their food is coming from. So if you see right now, even here in Washington, we have University of DC running an incubation program for young people who even are producing food for restaurants and others in their basement flat. They use 30% of their basement flat to produce food for the restaurants in DC. So they are very different models. They're not like models where you are having a large chunk of area, you're using whatever small area you have and have modular approach. So I think you will have to look at models which are costing $1,000, $5,000, $10,000, $100,000. You can't have one big industrial model in which you say, unless you have this scale, you can't do it. So this is what stops it from going to the developing countries. So how do we look at the costs and the returns? Cost per unit of investment, cost per unit of area, returns per unit of area, and develop that approach as we go along. So I think we would love to work with you on developing a use case from Korea based on whatever we have heard, in which we can enable learning from Korea to go to other countries. And definitely NIA is already working with a number of countries, and Ms. Wang's group is also already working in Vietnam and lots of other countries where the governments are asking us for this advice. So I'll stop here and thank you again very much. This discussion will go on and probably we'll engage with you more systematically as we go along on this. And how do we develop the Korea case? And then how do we develop a learning case for our countries to learn from? And then the proof of concept projects and pilots there. So I would really appreciate all of you and all the participants for staying and asking very encouraging questions. Thank you very much, and good morning, good evening, and good night. And thanks for staying so late in Korea and sharing this with us. We have recorded this conversation, and we're going to now use this to play this in Korea itself, because we have a lot of Korean startups with whom we work and all. So we will play this recording at another time for the Korean counterparts, where they will listen to this directly. And then we will also then hope that you can join at a good time in Korea to answer some of the questions which your Korean counterparts are asking you. Okay, so we will be in touch upon that. Thank you very much. And I also want to thank GI and Yunju to also raise very important questions. And Jisoo, our intern based in Seoul, doing a lot of spade work in making it happen. Thanks a lot, Jisoo, as well. Thank you. Bye-bye.